Okay, hello everyone, and welcome back to Simcyp Technical Webinar. My name is Xian Pan. I'm part of the Translational DMPK group at Simcyp. I will host the session today. So today's topic focuses on modeling TMDD using Simcyp Simulator version 24. So we have some expansion on large molecule TMDD model and also introduced the small molecule TMDD in this version. Before we start the talk, I'd like to kindly request everyone stays muted during the presentation. Should you have any questions, feel free to raise your hand or post your query in the chat box. We will have a dedicated Q&A session at the end where we will address all of them. We are recording the presentation, which will be available on YouTube shortly. Next slide, please. It's my pleasure to introduce today's speaker, Dr. Tom Liu. Tom is an associate principal scientist in biologics modeling team in Simcyp. She has led and actively contributed to various biologics projects. Her academic background is in chemical engineering. I'm glad to have her with us today. The talk today will cover the overview of modeling TMDD for large molecule drugs, including soluble target and membrane-bound target, as well as TMDD for small molecule drug. Without further ado, I will hand it over to Tom. Over to you, Tom.
Thank you very much, Xian, for your introduction. I will switch off my camera. So I'd like to begin the webinar by with the concept of target-mediated drug disposition. So it describes a non-linear pharmacokinetic phenomenon that is caused by the high affinity binding of a drug to its pharmacologic target. So since the target level is typically low and can be saturated, the TMDD effect is most pronounced at lower dose. And in version 24, we expanded TMDD model for large molecules, which account for the dynamic movement of soluble target. And also we introduced the small molecule TMDD model. So next, I'd like to have a brief introduction on the model features and then demonstrate how to set up a TMDD model in different scenarios in the simulator. So for the soluble target, such as cytokines and hormones, they can circulate throughout the body. And the existing full PBPK model of large molecule drugs is used to describe the dynamic movement of the soluble target and drug-soluble target complex. So the tissue distribution of the soluble target and the target complex by perfusion and the convection is described by the two-pole model. And also they are subject to the endosome uptake and the recycling. So since the target binding occurs throughout the body in each subcompartment, we can model the pH-dependent target binding in the endosomal space. So the reduced target binding at acidic pH enables the free drug dissociate from the complex. The free drug then binds to FcRn, which protects it from degradation and facilitates the drug recycle to the cell surface. In addition, we also provide the option to model the local synthesis of soluble target, so which is particularly relevant in the disease condition or inflammation. So now let's look at the simulator. So how can we set up a TMDD model for soluble target? So first, we would navigate to the population target screen. And you can see the target screen has been redesigned with in version 24, which is to accommodate the expanded TMDD model and make it more user-friendly. So we can add a new target by clicking the plus sign. And you see the expandable section is popped up on screen. And so in this grid, we can select a target, delete the target by clicking the minus sign. And also we can save the selected target into a XML file and also reload the target, predefined target, independent of the population. So now for the target, the new target, first we need to specify is a target for small molecule or large molecule. So one is a target for a large molecule. There are three types: a soluble, membrane bound, or membrane bound with target shedding. So when a soluble target is selected, so the required input for a soluble target includes the target abundance in plasma, the molecular weight, and the hydrodynamic radius. So it can be predicted by the molecular weight, or if users open the padlock, a measured value can be entered. So the removal rate can be also predicted from the hydrodynamic radius and also can be a user input. And we can switch on this option. To activate tissue synthesis, we can specify the local tissue, so and entering the synthesis rate in the local tissue. And when we navigate to the TMDD screen for a large molecule, so we can load a predefined target, or we can click the define new target and click the tile. It also directs us to the target screen, and we can define a target there. Now, so for a soluble target, is available when the conjugation is not activated. So if we activate this option with conjugate, we will see so that no soluble target is available from selection from the drop-down list. And so when we switch off this option and we load a soluble target here, so the available TMDD model for soluble target is one-to-one drug target binding and bispecific antibody model. So for the bispecific antibody model, the both targets can be soluble, or it can be a combination between a soluble and a membrane bound. So the first soluble target, we provide the TMDD option of the full TMDD and TMDD with quasi-equilibrium, and the target binding can be defined here. So since the elimination of the drug target complex is modeled where in the full PBPK model, where the catabolic clearance in endosome and the additional systemic clearance. So by default, the FCR and KD and additional systemic clearance are equal to the values for the unbound drug and bound antibody. But the binding of target can affect the parameter values. So we also provide a user input option. And so if we activate this option, define binding affinity, we can input a pH-dependent binding affinity for the target. So this for the at pH, physiologic pH, and this is for the acidic pH. And moving back to the membrane bound target binding. So we can also, in addition to the standard TMDD model, we can also model the target shedding. So that is the extracellular domain of the membrane bound target is set from cell surface. So this generates a soluble target. The soluble target circulates in the body and also has the capability of binding to the drug. So the membrane bound target can be located in plasma and in multiple tissues. And the such soluble target will be modeled using the new full PBPK model of the soluble target. So now in the simulator, so on the target screen, so this involves the selection of the target to be the membrane bound. So the first of all, we need to specify the target expression location. We can specify any or multiple tissues as listed in the table. We can specify plasma, heart, liver, and multiple. And also need to specify the degradation rate of the membrane bound target. And here in version 24, we provide the calculator. So that is used to converting the target abundance measured in tissue homogeneity to the abundance in the interstitial space. So for example, if for the lung, we have a measured value and we can convert it to the abundance in interstitial space of lung. And when we click apply, so this converted value will be automatically input to the lung. And we can also switch off this option, define regional target abundance. And so this means, so select the target abundance in the activated tissue has the same target abundance. And this can be used for the target abundance fitting. And so on the target on the TMDD screen, and we can load a membrane bound target. And so this tile shows the target is membrane bound. And when we hover the tile, it shows where the target is expressed. Okay, so if this target is the membrane bound target shading, so in addition to the target for the, in addition to the input parameter for membrane bound target and for the soluble target, additional parameter, the shading rate is also required. So on the TMDD screen, so now the target one is the membrane bound target with shading is loaded, and we can see, so the target binding parameters can be different between the membrane bound target and the soluble target. And for the membrane bound target, so the internalization rate of the complex is required. And so if the target is the membrane bound target, we can provide the TMDD model option, including the 1-to-1 drug target binding, 2-to-1, and bispecific antibody. And also, so if bispecific antibody model is selected, the targets can, both targets can be membrane bound. So when we move on to the small molecule drugs, so the generic TMDD models has been implemented for small molecule drugs. So the impact of the TMDD in small molecule on the distribution and clearance of drug can be different depending on the target location, whether it's in plasma or in tissue. So as a first step, in version 24, we focused on modeling TMDD in plasma, the targets in plasma, and all the targets in the liver intracellular space. So when target is in plasma, we can model TMDD in the minimal PBPK model or the full PBPK model. And when TMDD in liver intracellular space, the permeability limited liver model should be activated. And the TMDD model for small molecule is available at substrate slot only, and full TMDD model is implemented. In version 24, so this model is not applicable in pregnancy, pediatric, and preterm population, and animal simulator. So since the target for the large molecule and small molecule has been streamlined on the same screen, so now we need to switch the target for the small molecule here on target screen. And so the target in version 24 is either available in plasma or in liver. When we for a small molecule drug, so the TMD model is inactive by default. We need to activate the TMD model first, and then we can select the target from the drop-down list. Now, so the target one is in the liver. So for this TMD model, we provide the compatibility check. So when we click the check, so a warning, the validation check fields and a warning message displayed on screen. And in this case, it tells us to simulate TMDD in liver, so the permeability limited model must be active. Now, when we switch to the full PBPK model and activate the liver permeability limited model, and when we come back to the TMDD screen and recheck again, so in this case, now the check passed. So we provide the compatibility check to make sure we have the correct model to be selected. And in terms of the output, we have provided the option of the TMDD profiles for soluble target in the tissue interstitial space. So now the TMDD profiles is hyperlinked to the tissues on the sheet options. So when the tissues are selected, so we can output the TMDD profiles, the free drug concentration, drug target complex, free target, total drug, total target, total occupancy in the selected tissue. And also for small molecules, we output the TMDD parameters and TMDD profiles. And also, in addition, output is the total target concentration, the total drug including drug target complex, and also the total drug without drug target complex. And so I just give you a quick overview of the TMDD models available in version 24. And I'm happy to take any questions, and thanks for your time.
Okay, thank you, Tom. Let's now move to the Q&A session. So we'd love to hear what you're thinking or any questions you may have. Please use the raise hand feature if you like to speak, or just type your question in the chat box so we can read them aloud. While we're waiting for the questions come through, I like to ask a question first. So in the small molecule TMDD part, we know that targets are often distributed across multiple tissues rather than just to one location. So can we handle that? And is there any model expansion planned for this kind of a feature?
Yeah, so that's a good question. Yeah, so in version 24, so unfortunately only plasma and liver can be directly selected from the simulator, but we can use the customer Lua code to model the target in multiple tissues. Still, we know it's a limitation, and we would further expand the TMDD model to specify to be specified in multiple tissues in version 25. So in version 25, the TMDD model in small molecule will be more flexible, so allowing user to specify targets in multiple tissues. Yeah, okay. So it will be available in version 25.
Yeah, that's great. Maybe I could ask another thing about the large molecule part. So there are many cell surface targets for the anti-cancer treatment, and those targets shed their extracellular domain pretty soluble targets. So can model the ADC, the antibody drug conjugates, with a membrane bond target shedding?
Yeah, so I will show you this schematic of the target shedding model. So the TMDD model for large molecule is quite flexible since the expansion in version 24, and so we can model that, and it will be a complex scenario. And so for the ADC, all the DAR species of all the antibodies can bind to the soluble target and also the membrane bound targets simultaneously. So there will be the target binding of soluble targets in each subcompartment throughout the body. And yes, we can do that, but it's a complex scenario.
All right. So again, if you have any questions or any thoughts, or please just share that with us. You can raise your hand or type your question in the chat box. Okay, we have someone, Delia, so you can unmute yourself.
Hello, thanks a lot for this nice overview. I would have a question about the large molecule TMDD model. So because you showed that, pH-dependent target binding option for the soluble target, is there also a similar option for membrane-bound targets?
Sorry, no. So in version 24, no, it's only for the soluble target is so the location is in the endosomal space of the endothelial cell. But we know that some the membrane bound target, they can be internalized into the cell and they can have the pH dependent binding. Yes, so we can incorporate in the future, and but no, currently it's only for soluble target.
Yes. Okay. Thanks a lot.
Thank you.
Okay. Anyone, I think you can unmute yourself.
Hi. Thank you so for this introduction. I just have a question on the drug the receptor degradation rate and synthesis rate. I know for the Simcyp version 23 and previous versions, there was relationship between the receptor synthesis, receptor degradation, and receptor abundance. So basically, it allowed us to enter the receptor abundance and the degradation rate, and it will automatically calculate the synthesis rate. I'm just wondering, is that still true for this newer version?
Yes, that's true. So that depends on the target. So for the membrane bound target, is a membrane bound all with the membrane target shedding. So if it's a membrane bound target, yes, that's true. So the synthesis rate is calculated from the degradation rate and the abundance. But when with the shedding, so that's the membrane bound target. There's two ways of the degradation or elimination of the membrane bound target. One way is by degradation, or the other and the other is by shedding. So now the synthesis rate is composed of the synthesis rate and degradation rate, and the sum multiplies the abundance.
I see. Thank you.
No problem.
Okay. So if there are no further questions, we will now conclude today's webinar. Keep going. Thank you, Tom, for the great talk about the TMDD module in the Simcyp simulator version 24. As you can see, we have upgraded the interface, and hopefully it will be more user-friendly, and I would love to hear your feedbacks on this. And thank you to everyone for joining us, for your attention and active engagement. Should you have any additional queries later on, please don't hesitate to get in touch with us. So our next technical webinar is scheduled on the 16th of April about the new functionality in Simcyp Simulator version 24 for the trial design and optimal dosing selection. So if you are interested in it, please register through members area. Once again, thanks for being with us today. We looking forward to seeing you soon and wishing you all a lovely day and goodbye.